we have talked about some tools, which is very simple. For the solving the problem. Now, we will actually extend some kind of tools to solve the problem. This is very, very important. Mass balance. Well, as I already talked, if you really want to do good, diet, well, actually, mass balance is not that good because, as I already talked, a bowl of the chicken fat and a bowl of rice is totally different. Well, we can, at those materials, calories actually hidden, right? But we are not actually dealing with the energy balance for your diet. We want to solve the environmental problem. So just to focus on the mass balance at this time. Right. Before starting the mass balance, the first question is, how fast do things change? Well, just think about this. If you just, have a job in the engineering consulting firm, well, let's say Montgomery and Watson or Black and Veatch, you should really pronunciate very well. And you work as a research consultant. What is the most important thing when your customer drop by your office? What is the most important factor when you decide or when you suggest some kind of new novel engineering technology, environmental technology to your client? All right, at first time, if your customer just drop by your office, you just talk to them and have sit, and then you may ask what kind of problem you have, right? And then, well, actually, because you are the expert, you really need to say something to solve the problem, right? Maybe in a couple of minutes, you just pretend to know everything about the environmental problem, and they say something. So at first time, what kind of suggestion can you give to your customer? Is the suggestion, you have the suggestion. What is the standard? What is the factor which significantly influence on your suggestion? Is question too difficult to you? What's your standard? How much? Okay, anybody, any opinion? You guys understand what I'm asking? Ms. Reed. Okay, I will just explain my question again. You're consulting agent in Dr. Rees and Associates. You have job there, right? After graduation, fortunately you have job at Dr. Lee and Associates. You are one of the associates there, right? So one of the owner of the let's say gas station drop by your office, and this just to talk to you, he just explained his environmental problem. One of his underground storage tank actually broken, so the gas actually leaked out, and he just want to ask you what kind of remediation technology does he want to use to clean the contaminated soil and groundwater? Well, because you're an expert, the first time you need to pretend you know the environmental problem very well, right? Well, a couple of seconds, if the your customer became to know you don't know anything of the environmental problem, well, your customer don't want to visit you anymore. So the first time, at least you need to pretend you know everything about that. Is it right? Yeah, that is very, very good. And then you need to say something to him, right? Right? Let's say that is kind of one novel remediation technology to clean the contaminated soil and groundwater. Well, you just give him one nice remediation technology. So what would you suggest that technology based on your standard? So what is the standard?
I would think the most important standard would be how much it costs to make how much revenue.
Yeah. She said one most important factor, money. The important thing is you are the owner of the jewelry store. Well, the first time you just look at him or her customer, and then you need to find out how much she and he have right now, so that you can suggest, the appropriate jewelry to them. You just like the student, can you suggest diamonds to him? Is it appropriate? Let's say your customer, he's just like the owner of McDonald's, or the owner of the Toyota. So you can actually suggest him or her with very expensive renovation technology. Maybe you can use catalyst made of gold, silver, But if your customer, it just looks like farmer. The farmland is fully contaminated by, toxic chemicals. He need to clean the contaminated soil, right? So, do you want to actually, suggest the novel technology with diamonds catalyst? So, money is very, very important for engineering consultant. And what is the another significant factor? Well, actually, that factor is related to money. What is that? Effectiveness. Yeah, well, effectiveness is kind of, not the objective. Effective can be kind of results of that factor. Yeah, that's very important. So if you are an engineering consultant, you really need to think about the time and money. Think about that. The owner of Starbucks in the middle of the Seoul, maybe he can, billion, zillion, one actually a day. But some government or officer just drop by and please remove the contaminated soil, clean the contaminated soil under your store. He may want to clean that contaminated soil in a day, and then he wants to continue his business actually. What about the farmer near Gongju area? His farmland is fully contaminated with some pesticide. So, local governmental officials just drop by and talk to him. You need to clean that farmland that first time, and then you start to, basically your farmland. He actually need to clean the contaminated side, but mostly the farmer doesn't have much money. At that in a moment. You really don't want to actually, ask him, or the farmer actually don't want to clean the farmland in a day, actually. So, well, as a expert, you can suggest him maybe using natural attenuation, which related to natural healing power. So engineers actually didn't do much on engineering on that farming, right? But very cheap. And also, in this time to clean the contaminated area. So, Starbucks owner and the farmer, you really need to think about the money and the time, right? Here, this is not the environmental management course, so I'm not focusing on the money things, but we will focus on the time, which related to efficiencies, right? All right, so how fast do things change? This is very, very important. If you're a scientist, if you're an engineer, the time is very, very important. So some useful example problem, what is the delivery rate of some pollutant to a compartment? And how long would it take for some pollutant to clear out of the rake? This is very, very important. So time related, right? And the movement related. So if you can manage the movement of the pollutants, and if you can actually prevent or manage the time of pollutants movement, well, actually you can prevent the contamination phenomena in the natural environment or engineered environment. This is very, very important, right? And to solve these questions, two skills are needed. Steady-state mass balance and non-steady-state mass balance. Well, actually, mass balance things actually, is basic tool to solve chemical, civil, mechanical engineering problem, actually. Mostly, chemical engineering problem. If you can settle mass balance very well, you can actually solve chemical engineering problem, environmental related problem. If so, what is the steady state? I'm in the steady state. What is that? Yeah, no change with respect to what is most important thing in environmental? We already said that, right? Time. Right. So we'll talk about the time and talk about some significant factors which related to environmental problem. What is important environmental factors? Well, there is some kind of environmental problem occurs. How can you evaluate what kind of things do you want to use? This is the problem, this is not. I'm sorry. Yeah, well, it is important. Here, you can actually catch the concentration of some anion and cation, right? So you believe this level of concentration is very good for your health. What about increasing the concentration of this anion, sodium, calcium, potassium, by increasing by 100 times or 1,000 times? And then if I gave it to her and drink it, what happened? Yeah, well, actually, I'm killing it. Right? Killing. So, as I already told, time is important factor for environmental problem, and concentration is very important environmental problem, material. So So you really need to think about that. So the concentration, environmental related factors, there's no change with respect to time. For example, flow is also important. So flow in and flow out are the same, actually. This is steady state. And non-steady state, you may expect this is kind of uncomfortable, state. So unstable state. So the mass in, flow in, is not the same flow out. This is the non-steady state mass balance case. All right. As we already taught, environmental compartment. So what is the environmental compartment? You guys know the meaning of compartment, right? So environmental compartment is any definable unit of environment. For example, the Earth, or the Earth is entire atmosphere, could be environmental compartment. You could be environmental compartment. Lake Michigan could be, and KAIST also, and a house, and the air dome over the New York City, or in KAIST, over desert area. So this is environmental compartment. Right. Okay, let's do some steady state mass balance things. Just let's imagine some environmental compartment. For example, a lake. Here, this is simple environmental compartment with some flow in. So, let's say this is river A, and B. So we could say flow in and flow out. So two rivers and one lake. So lake compartment, river flow in and river flow out. And also flow, this is flow rate. Could be kilogram per day. Are you having fluid mechanics, dynamic class in this semester? No? Well, I think in civil engineering, if you really want to, get involved in environmental science and engineering, fluid mechanics is very, very, good, basic information. So have it. Also, the total amount of material in compartment, we call it a stock, or sometimes we call it burden. I don't know. I just removed this, actually, but Lan Heist actually added this burden because he thinks contaminants, so contaminants are burden anyway. So in case F in equals F out, the compartment is in steady state, right? And residence time, we call it tau, not T. Residence time is average time an item of stock spent in a compartment. So this is very simple. Just to put some, color dye here. This is black color. Let's say just a particle, and then the residence time is the time of the stay time of this particle in this compartment. Like this is the rate. Pretty sure the molar quantity. And the unit of the residence time is time. So it could be day, second, and Well, anyway, the time is very, very important factor for environmental engineering and science. And the next concept is rate constant. We just using small k, and which is reciprocal of tau. So units of time reciprocal. So k equals 1 over tau. So tau equals stock divided by the flow in or flow out. And you can definitely get a flow stock divided by tau and stock times rate constant. Okay, let's do some example. Silly example. I don't even know. Most of the students in university students in Korea, they want to graduate in 4 years, right? What's your country's case?
Also 4 years.
4 years. What about you?
5 years.
5 years. 4 years. Right. So, most of the students in the United States, let's just say, general students in state university case, they spend mostly 4.5 or 6 actually, because they just want to, enjoy the university life actually. Well, anyway, the problem is Indiana University. Well, actually, this is the university Run Heights in, has an average of 34,000 undergraduate students, and the average student spends 4.4 years getting their degree. Assuming no one, leaves early, IU, and what is the graduation rate? So how can you solve this? Rate, stock divided by residence time. Right? So this is very silly question, right? But if you just remove student here and put it contaminants here, and then average student spends the time, just remove this, and the residence time of the contaminants. Well, this is very simple environmental problem, actually, right? And it has also really a solution. As I want to talk, 34,000 students in IU, and they usually spend 4.4 year. So 1 year, almost 7,700 students graduate. So, the actual number is around the 4,500 students per year. So the success rate is around the 6%. Wow. So in Korea, mostly KAIST in 4 year, maybe most of the people, maybe 95% graduate, right? So this is very, general and very special university. All universities in Korea, actually. Maybe Ukraine, maybe France, maybe Azerbaijan. All right, good. Okay. The second problem is, this is very, similar to the first question. What is the residence time for water in Earth's atmosphere? Which is much more like environmental problem, right? Well, if you just look at the solution, this is very silly. But if you just remove this, this is kind of, the question. You can find it in nature and science. So the first time, the solution is we need to know the global precipitation. Precipitation actually provide the water to the Earth. The global precipitation rate is 5.1 times 10 to 14 cubic meter per year. So global, well, how can we get the global precipitation rate? Here, the depths of rain and snowfall around the world, which is 1 meter per year times the surface area of the Earth. So you can get it. And then we need to know the stock, right? The total amount of the water in the Earth's atmosphere at any time. So, which is 123 times 10 to 13 cubic meter. Well, this is just a given factor. So calculation, the stock divided by flow rate, you can have 9.3 days. So, which means you usually have rainfall every 9.3 days. Is that wrong? Right? So this is kind of, sort of a silly, overestimated or underestimated. Well, in Korea, this is totally wrong. 95% of rainfall actually, focus on August. So this actually, gives wrong estimation. But the important thing is, this is better than nothing. Yeah, have you ever tried this estimation before? If you don't, just shut up and wait there. Well, as I already talked, the concentration is very, very important because even the general ordinary people, I really don't know. When you purchase a bottle of water, you usually check the concentration of cations and anions in there. Yeah, you don't have any ideas, right? But most of the people actually very familiar with concentration. So although they are not the ordinary, experts, they just ask you what is the limitation as a concentration. So not BMS actually, right? So important thing is sometimes concentration give very positive and very good estimation because it can actually give kind of ratio. So big problem with this approach, the approaches we have used solving the environmental problems previously, we often do not know the total mass in a compartment, but we know the concentration, which is stock divided by volume. Could be milligram per liter, could be gram per kilogram, and well, actually volume is not the kilogram though. And here, volume is volume. So stock equals concentration time volume, and you can get flow CD divided by tau, which is very easy. Well, this is very easy, but I bet you, this simple equation can be very useful when you solve midterm exam problem. All right, let's look at the sample problem. This is very simple, but as I already taught, we just change a student by natural some contaminants. And we added some more factors related to concentration, flow of contaminants. All right, here. Natural sources add sulfur dioxide. What kind of sources can be added for sulfur dioxide? What is the most significant sources? Huh? Pardon? Water. How can you water can provide sulfur dioxide? What kind of water? SO2. Or?
Chemical and metal industry. They use acid like with SO2 to clean different metals, especially different.
Yeah, well, if you guys just burn the chemicals, burn the fuels, burn the coals, well, you can have SOx, SOx, right? So SO2 you can have it. But what is the natural source of the sulfur dioxide?
Volcano.
Yeah, volcano. Volcano is the biggest, actually, natural source of sulfur dioxide to the atmosphere at a rate of 2 times 10 to 8 tons per year, which is very, very huge. And the background concentration of atmospheric SO2 measured in remote area, maybe near the Daejeon, Gongju area, the anthropogenic man-made source are not likely to relate it. So the concentration is nearly above the 0.2 ppb, which is very low, right? This means 0.2 times 10 to 9 actually parts per billion. If so, what is the resonance time of atmospheric sulfur dioxide in remote area? How can you calculate this? Well, we can use the tau equation, so you can simply calculate it, right? And also, so why is this important? What is good for what is bad for the staining of sulfur dioxide? Is this needed, or do we need to prevent it? A lot of what? Okay. So, well, actually, because you want to majoring in the environmental science and engineering. Well, it is just like the, you can be much more, comparative, actually. Comparative. As I already taught, a bowl of rice is good for you before distress, but if I order you maybe, one bowl of rice, well, I am killing you, actually. So the, comparison is important. As she said, the amount, the concentration, the limitation, it exists. Well, it could be environmental problem. Well, anyway, let's do some calculation. Well, the first time, what you should do is, as I already taught, you really need to understand the problem, right? And then set up the boundary. If you can draw a figure, schematic diagram, which is very good to solve the problem, actually. Especially for the mass development. So the first time you need to know the stock, which will be concentration times of volume of the Earth's atmosphere. Well, we already calculate the volume and also the concentration of atmosphere at previous lecture. So the stock is 8.2 times 10 to 11 liter, and then we need m in tons because the question, the rate is related to actually ton. So the stock 8.2 times 10 to 11, one more 22 per liter, and one more 6 per gram, and ton gram 10 to 6 times, and you can have 2.3 times 10 to 6 ton, right? So using simple tau equation, if you put it 2.3 times 10 to 6, and then divide it by 2 times 10 to 8, you can have 4.38. Wow. So the sulfur dioxide that actually, appeared in the air, it stays actually 3D. Right? Okay. This is more homework. Well, super dioxide is not that, significant if you think. What about the DDTs? As I already taught, your grandfather actually used DDT to expel the lice of their head, actually, which cause cancer, carcinogen, we call it. So, well, this is very, very, interesting. Well, I cannot say interesting, serious thing. Well, nowadays, some television program, I really don't know how can I, translate it into, English. But here's, Antarctic, maybe. Well, so as I already asked you at first class, polar bear is polar bear in the Antarctic area. So what is the resident of the Antarctic area? Right. So penguin stay there in Antarctic area. Polar bear, you cannot find them in the Antarctic area. So North Pole, right? So interesting thing is, when I was a graduate student, Ron and some researchers went to the not the Antarctic area, some near Antarctic area near the Canada, and we actually had planned to take some sample from the polar bear's blood, actually. We just want to know some kind of chlorinated chemical exists in polar bear's blood. Because there is kind of interesting study. Some toxicologists actually find detect some chemical compounds in their blood. Well, actually we did some sampling. Well, actually I'm not the hunter, and well, we actually got it from the other research team actually. And then we can find very interesting, research analytical results. We can find some brominated chemicals. We can find some, chlorinated chemicals. Brominated chemicals from the native chemical. We call it PBDE. Polybrominated diphenyl ether. Think about that. The concentration is very high. We cannot believe, we actually cannot set up our hypothesis. Polar bear actually, take this chemical from the nature. I mean, that means polar area. So, what is the main component of the PBDE? PBD is actually fire retardant. I don't even know. 3 or 4 years ago, actually, there is curtain, in this room. But curtain usually include such kind of chemical in case, fire. So you guys don't want to, burn. So the fire actually include fire retardant. If so, let's just set up the hypothesis. The polar bear had used the curtain in polar area. How can the polar bear can fire retardant, which is the main source, main component of the curtain? Well, as an environmental scientist, you need to set up hypothesis how the polar bear can get the PBDE. Or is there any chemicals which contaminate polar bear in the polar area? Have you ever heard there is, chemical industry at the polar area? So how can the bears, you guys know, if you have seen the Coca-Cola advertisement, the sales actually, popped up and, take the bottle of Coca-Cola and, giving it to the polar bear, family, right? So that is right, actually. Polar bear really like the sales, actually. Anyway, so the Coca-Cola drinking, which polar bear is drinking, does it have a PBDE in there? If so, Coca-Cola include PBDE? So what kind of hypothesis can you set up to solve this problem? Why the polar bear, has it in his, blood?
You would show other countries carbon.
Yeah, that was one potential hypothesis we can have in our research group. So maybe here, maybe polar area here. So most of the curtain industry located from the east coast. So our hypothesis is the PBDE actually industry emits PBDE related chemicals, and it just flying over the air and then just falling down near the North Polar Sea actually. So the plankton can consume these chemicals, and the fish can eat the plankton. So this is kind of a pyramid. Actually, the concentration of the PBDE is very low here, but the polar bear, which is at the top, has higher concentration of PBDE. So we just measure the concentration of PBD of plankton and the fish, and also shrimp, and also seal and polar bear. The concentration actually goes up. Well, anyway. We actually use this simple, calculation equation to verify our environmental problem. This is interesting, right? You guys can use this to solve very simple, very complex environmental problem, actually. All right. So, such kind of long-range transfer of contaminants can happen. And also, this is very, we actually did one more interesting research work. We want to detect PBDE, the fire retardant, in mother's milk, human mother's milk. So we get some sample from Sweden, and we take some sample from all over the world, and we just want to find out which area, which human race actually have higher concentration. Cool. Is there any reason you are making quizzical face on me?
Was there a difference?
Difference? What difference? Yeah. Maybe if the third world, they may have much more industries there. Sweden, you cannot find the industries very well. So we actually analyze sample and get some trend actually. Well, anyway, For solving the problem, we also use this simple calculation. You can find it at the science, and you can find it at the environmental science and technology. That's all. All right? Okay. You want to solve this problem. Let's say carbonyl sulfide, COS, is present as a trace gas in the atmosphere at a concentration of 0.51 ppb, which is very low, but it can cause you cancer. Its major source is from the ocean, at a rate of 6 times 10 to 8 kilogram per year. What is the residence time in year of COS in the atmosphere? The answer is 9.3 years. You do, for small homework. Okay. Well, this is another interesting problem. I'm not going to do this, right now. Well, why I show you this slide as a way of, when you want to solve the problem, please read the problem carefully and then fully understand. The next step is set the system boundary. This is very, very important. If you draw the schematic diagram of the problem, well, you already solved 50% of the problem, right? Just draw the schematic diagram and put some factors, and then start to solve the problem. All right. I think that this is it for today. And any question and comments on the lecture material today?
This line, post on the this line.
I don't think I understand you. I'm very sorry. Take it easy. All right.
I want to.
You want to?
I want to read. Slide.
Read
I want
with
to see
slide.
slide.
Mm-hmm.
So where I can find slide
This one, the 50 files, you can find it in homepage.
in homepage.
Yeah.
So which section in homepage where I can find?
You are so demanding, man. If you just go to the EGRL homepage, I'll just show you. I think that I already show you my homepage.
Because I just on lecture most section that I see some video.
Yeah. You can see that. Yep. You can find the lecture. And the lecture here, this is the syllabus. You can check the syllabus here. Well, actually, I didn't actually set up the schedule of the environmental engineering. I will do it very soon. And lecture notes. You can find the clips, video clips here. And you also find the chapter 1. This is the file you want to see. And homework 1, also you can check it here. And chapter 1, you can have maybe 5 small environmental problems, which is small homework, which should be submitted in a week. Because I put it Monday, you need to submit it Monday 2 weeks later, and Monday 1 week later, you need to submit the small homework. Got that? Because some of you sent email to my teaching assistant, and she told me everybody, asked her when is the due date. I think I talked to you several times, maybe 100 times. So please enjoy my show and also enjoy, fully understand? Okay, if you don't understand, just raise your hand.
A small homework. That one homework number one. That is like big homework and very small homework.
Well,
This is a problem that you told us in a lecture during lecture.
yes, in lecture slide, yeah, here, I already told you, this is the small homework in the box. So, well, as I already told, you can have different, solution, and you can have different, answer. Well, as I already taught, the answer I put it as a numerical form. That is just kind of, one possible answer solution. If you set up different assumption and different, well, the solution definitely can be changed. So how to approach and how to solve is important. The number is also important, but those two previous ones, I will put much more credits. Right? Anything else?
I don't understand the difference between the small homework and action. So the small homework is the one on the
In the box.
files.
Yeah.
So we have to hand it in.
You need to, yeah.
So that's due next week.
Well, actually, I just put the my 50 slide, right? My 50 slide, kind of, last Monday, after finishing chapter 1. So that day is the start of your small homework and your, regular homework.
They both due in 2 weeks.
No, 1, 2.
One week
Small
and 2
homework,
weeks.
yes. For small homework, you need to you have 1 week, and regular homework you can have 2 weeks. If you think 2 weeks is not that enough for solving, well, you can ask me. I can give you much more time, but I don't think if you just check the problem itself is very hilarious. So. Try it, and then ask me.
So if you put up like a slide for chapter 1 at the same day and you say that's the start day of the small homework, then do we submit all of the small homeworks in one chapter in one day?
Well, I will let you know. Small homework. Well, I think the best thing you do is just solving the problem. Right after having the lecture is fast, but I cannot actually put this, slide every lecture, after lecture, because these are all the copyright, related work. Well, I'm actually doing, wrong thing, but because I also have